Hello and welcome to Algebra 1, Chapter 6.5, and today we're going to be solving open sentences involving absolute values. So, what is an absolute value? The main real-life use of an absolute value is for margin of error. And so let's say you're working at a potato chip factory and you're making 16-ounce bags. That is how much can you get away with not being exactly at 16 ounces. Is 15.5 ounces okay? Is 15 ounces okay? Is 4 ounces okay? If you only put 4 ounces of chips in a bag. And so that margin of error is called the absolute value. Absolute value in a definite math sense is the distance a number is from 0. And if you think about distance cannot be negative, okay? If you travel in a car, you're always traveling a positive distance. Distance can never be less than 0. So an absolute value then is always going to give you a positive value. So the absolute value of a number is always written in two vertical bars. So here we have the absolute value of n. And just as some examples, what is the absolute value of 3? Or how far is 3 from 0? It is 3. What about the absolute value of negative 5? It is 5. The absolute value of 7 is 7. There are 3 absolute values that we are going to consider, 3 open sentences that we are going to consider. When the absolute value of x is equal to n, so when we have an equation, and when we have an inequality, so when the absolute value of x is either less than n or greater than n, and they can also be equal to. Okay, so just when you're solving absolute value equations, you are going to consider 2 cases. Because if the absolute value of x, let's say, equals 3, what could x be? Well, x could be a positive 3, because the absolute value of 3 equals 3. Or x could be a negative 3, because the absolute value of negative 3 equals 3. And thus there are 2 answers, and so we have to consider 2 cases. So x could be 3 or x could be negative 3, and they're both correct. So what does that look like if we have something like this? So if we totally blacked out what was in this inequality, whatever it is, it's equal to 7. So this inside of here, whatever this is, has to be either equal to 7 or it has to be equal to negative 7 because the absolute value of negative 7 equals 7. Okay, and so to start with, it has nothing to do with what's in there. Then, though, we're going to say, okay, well, what's in there was the 2x minus 1. So either 2x minus 1 has to equal 7 or 2x minus 1 has to equal negative 7. And then these are our 2 cases. So you are going to solve each equation. And there's one answer. I really like the fact that when you solve these, they solve the same way. And there's your other answer. They don't have to be opposites of each other. So 4 would give you an absolute value that was 7, and negative 3 would give you an absolute value of 7. So the next thing we want to do is just solve and graph. Okay, so whatever's in here, whatever this is, has to be equal to either a positive 4 or it has to be equal to a negative 4. And take note that an absolute value cannot be equal to a negative number. So if you had something like the absolute value of x equals negative 3, that can never happen because when you take the absolute value of a number, you always get a positive number. So we have our 2 cases set up. You're going to solve them, so subtract 2 from each side. Y is 2. Y is negative 6. And if you are graphing equalities, this is just where you put just a point on the number line. Make my number line longer here. So we are just going to plot 2 and negative 6. And you would be done. Now, before we leave this example, I want to show you something. If we find the midpoint between 2 and negative 6, so what is the midpoint between 2 and negative 6? It's negative 2, right? And so this would be 1, 2, 3, there's 4 there. 1, 2, 3, 4 there. There's an equation that you're going to need to know, and it's the absolute value of x minus the midpoint equals the distance from the midpoint. So make sure you have that written down. And in this case, if we did x minus the midpoint is negative 2 equals the distance for the midpoint is 4, well that's x plus 2, because of minus the negative there, equals 4. Notice that's our equation we started with. So what we're going to do next is we're going to start with a graph and write an equation, but you really need to know this formula right here, so make sure you have that written down. Okay, so can you write the open sentence for this graph? And we know it's an equation because you just have 2 points. So first of all, what's the midpoint? And then really, first of all, notice what you're counting by. Counting by 2's, okay. Because if we go, well, there's 2, and there's 2, and there's 2, and there's 2, and we say, well, then it's halfway between. Well, halfway between is at 1. Okay, so then how far did you go on either side? So we went 2, 4, we went 5 on either side. So remember our formula was x minus the midpoint. And the midpoint is at 1 equals the distance from the midpoint, which is 5. And there you have your graph, but it really pays to know your formula. All right, so the next thing we're going to talk about is graphing absolute value functions, and these are going to be graphed on a coordinate plane. And just like anything else, you're going to make a table of values. Okay, that's how you're going to do it. Make a table of values. You need enough that you can completely see the graph. I would recommend 5. And just an FYI, they are going to graph a V. Okay, so you need to graph enough until you find this V. So here's the first one, f of x equals x plus, the absolute value of x plus 3. And remember, f of x is the same thing as y. So when you go to make your table of values, you got x and y. So let's just start with x is 0. So if you put in 0 for x, you're going to get the absolute value of 3, which is 3. So 0, 3 is one of our points. And then maybe we put in 1. So you can get 1 plus 3. So what's the absolute value of 4? It's 4. So we get 1, 4. Okay, what about if we put in 2? 2 plus 3. Get the absolute value of 5, which is 5. So there needs to be a point where you go, okay, if I keep putting in larger numbers, I'm going to keep getting a larger number, and they're going to look like they're in a line. So what if we do negative 1? Negative 1 plus 3 is, if it's a vertical, is 2. Absolute value of 2 is 2, okay. And by the way, you don't have to go in order, but we're gonna keep going. Negative 2. So that's going to be 1. So I still get 1. And I know it looks like we got a line, but hold on. Give me one more moment. Negative 3. Well, that's going to give us 0. Absolute value of 0 is 0. Okay, here we go. Negative 4. Negative 4 plus 3 is negative 1. What's the absolute value of negative 1? positive 1. There we go. There was our turning point. If we do one more, if you do negative 5, you'll see that it hits right there. There is our V that we were looking for. Now that we've done all that, I want you to notice that here this says plus 3, and you came this way, you came to the left 3 spaces. So I want you to keep that in mind. Alright, one more example to do. We're going to graph again. This time we're graphing the function g of x. We're going to still have a table. And what did you realize from that plus 3 in the last one as to where our turning point was? So this time, where would you suggest we start? Hopefully you said negative 2. So if we have the absolute value of negative 2 plus 2 plus 3, right? So that's going to be the absolute value of 0 plus 3, that's going to be 3. So at negative 2, we're at 3. Okay, so let's try negative 1. Negative 1 plus 2 plus 3. So that's the absolute value of 1 plus 3. So that's going to be 4. So what if we try negative 3? Negative 3 plus 2 plus 3. That's the absolute value of negative 1 plus 3, which is 4, because you got absolute value of negative 1 is positive 1. There's my turning point. Go ahead and do one more on either side. Do 0 and negative 4. So if we put in 0, we're going to get 5. If we put in negative 4, we're going to get the absolute value of negative 2, which is 2 plus 3 is 5. Yes, they should be symmetric. There we go. All right. We will do a few more examples in class, but let me know if you have any questions. Have a good day.